stay together this night. 'Cause the place seems still enough when the smoke is going down. When the smoke is going down. When the smoke is going down. When I look into your eyes and see love restrained, when I hold you, don't you know I feel the same? Cause nothing lasts forever, and we both know hearts can change. And it's hard to hold the candle in the cold November rain. We've been through this such a long, long time, just trying to kill the pain. Yeah. Lovers always going, lovers always going. No one really sure was letting go today. Walking away. If we could take the time to lay on the line and caress my head, just know that you were mine. Oh, mine. If you wanna love me, then darling, don't refrain. In the cold November.
Dragon Ball Super Theme mode has arrived. In this mode, we've added several.
You need some time on your own. You need some time all alone. Ooh, everybody needs some time on your own. Ooh, don't you know you need some time all alone? I know it's hard to keep an open heart. Even friends seem bound to harm you. But if you could heal the broken heart, wouldn't time be out to charm you? some time on my own. Sometimes I need some time all alone. Ooh, everybody needs some time on their own. Ooh, don't you know you need some time all alone?
Good afternoon, ladies and gentlemen. The coordinator of the committee, Ibu Professor Sri Sumarni MPD, and the Honorable Visiting Professor from Utah State University and Brigham Young University, Professor Katie Kip Trundle and Professor Laura Wheeler, and the Honorable all the Head and Secretary of Department, Coordinator of Study Program, Lecture, and ladies and gentlemen, both in this room and in virtual room. Assalamualaikum warahmatullahi wabarakatuh. I am Susi Amizera. It's such a great honor for me to be here as a master of ceremony of this general lecture. And I would like to welcome you all to this session about engineering design in STEM education with Professor Laura Wheeler from Brigham Young University. At Faculty of Teacher Training and Education, Sriwijaya University, on Wednesday, 26th of July, 2023. Ladies and gentlemen, now I would like to invite the coordinator of the general lecture to deliver the program report. And now, please welcome Ibu Professor Sri Sumarni, MPD. The time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. The Honorable Dean of Faculty of Teacher Training and Education, Dr. Hartono, MA, the Honorable Vice Dean for Academic Advice, Dr. Rita Indrawati MPD, the Honorable Vice Dean for General Affairs and Finance Nyimas Aisyah MPD PhD, the Honorable Vice Dean of Student Affairs Dr. Ismet MSG, the Honorable our visiting professor Evers, this event Prof. Laura Wheeler from Brigham Young University. Welcome to Palembang and welcome to Sriwijaya University. The Honorable invite guests and all participants. I am proud to extend my warm welcome to all of you at this Stadium General Engineering Design in STEM Education. On this occasion, we gather to celebrate and promote innovation in STEM education, science, technology, engineering, and mathematics by exploring the crucial role of design, engineering, and learning. These themes highly relevant considering and repeat change in the world of technology and increasingly complex global challenges. As educator and stakeholder in education, we have witnessed how the design engineering approach has significantly impacted the learning of future generation by strengthening students in understanding and skill in designing and creating innovative solutions, while we contribute to preparing them to face a world full of challenges and opportunity. We sincerely express our heartfelt gratitude to Professor Laura Wheeler for the time, dedication, and exceptional knowledge you have shared. The material you presented not only speaks our mind, but also offered a fresh perspective on understanding the importance of design engineering in STEM education. Your contributions are truly institution meaningful to all of us and inspire us to face the future of education with enthusiasm. Furthermore, this event was extended by more 100 participants who registered both virtually and on-site for all over Indonesia. I believe this event inspires all of us to remain committed to providing quality education. Finally, I would like to thank all the committees who have prepared this seminar and hopefully this event will run well until the end. May this be a memorable and exciting experience for us. Thank you and enjoy the Stadium General. Wassalamualaikum warahmatullahi wabarakatuh.
Ladies and gentlemen, now we are ready to move on to our main agenda, and we are very excited to listen to our speaker, Professor Laura Wheeler from from Brigham Young University, with our moderator Najlatul Fatiha, and also the interpreter Bapak Dr. Farhan Yadi, STMPD, the lecturer of Mechanical Engineering Education Program. And now the time is yours.
Good afternoon, ladies and gentlemen. How are you today? Okay. Have you got your lunch? Yes? Okay. So I believe all of you already got your lunch, right? Okay. Welcome to the Stadium General Engineering Design and STEM Education in Faculty of Teacher Training and Education, Sriwijaya University, Palembang, Tuesday, 26 July 2023. Before we start, I will introduce myself. My name is Najlatul Fatia from Education Department, and my partner is Mr. Farhan Yadi, STMPD. But first, let me say thanks first to the Honorable of the Dean of Teacher Training and Education Faculty, Dr. Hartono MA, the Honorable of Vice Dean for Academic Affairs, Dr. Rita Indawati MPD, the Honorable of Vice Dean for General Affairs and Finance, Nyimas Aisa MPD PhD, the Honorable of Vice Dean of Student Affairs, Dr. Ismet MSc. Thank you for the chance so I could be here as a moderator. And also for my lectures, students from Department of Teacher Training and Education Faculty. Some of them are here and some of them are in Zoom. Okay. In program visiting professor from Brigham Young University, USA, to Teacher Training and Education Faculty, we will not miss a golden opportunity to get a lot of experiences and new information about engineering design in STEM education. For that, we have a speaker who is already here. That's Professor Laura. Hi.
Hello.
Okay. How are you?
I'm good, thank you.
Okay. So I will guide the Stadium General. Professor Laura will present for over 60 minutes. And after that, after she have given the topic, we will discuss the topic. Okay. And if you have question, you can here, for the participant here, you can directly raise your hand. And for the participant in Zoom, you can chat in the box, okay, the chat box. And before Professor Laura present her presentation, I would like to read a little bit her profile first. Now, Professor Laura teach at Brigham Young University in Department of Civil and Environmental Engineering. Is that true?
Elementary or primary education, science education, or STEM education.
Okay, so it's the specifically. Okay, sorry for my mistake.
No, you're good.
Okay.
It's very new. I just am starting there. So
Okay. And okay, so it means your spatial basic is in engineering, environmental engineering. That's right.
so my background is in STEM education,
Okay.
but specifically with being a science educator. I was a science teacher in the schools for many years.
Okay, that's great.
Yeah.
Thank you. Okay, so without further ado, it's time for you, Professor Laura Wheeler, to present the topic, and the floor is yours.
Thank you.
Okay.
I need to share. I'll start by telling you a story. The story goes something like this. There are teachers all over the world. You have science teachers, math teachers, and you have primary school teachers. And then the researchers said, well, we also have this field called engineering. It's very, very important. It's important for solving problems in the design world. Where does it fit in education? Do we put it with math? Do math teachers teach engineering? Or should science teachers be the one to teach engineering? What should we do? Or should we have separate classes all by themselves? Engineering classes. But where does it belong? And for a lot of years, engineering got lost and they didn't know where its place was in K-12 education. Where was its place? Well, in 2010, in the United States, they decided that place belonged in science, that science teachers should have the responsibility to teach engineering. But wait a minute. You can't just teach engineering without mathematics, and you also can't teach it without technology. There has to be this way where we can integrate all the learning together, and they call this STEM education. But it's very difficult because not every school has a STEM teacher. A STEM teacher would have to be knowledgeable in science. Well, which science? All of the sciences? And technology and engineering and mathematics? You can see that this is a very intriguing and interesting challenge. Where is the place for engineering? Where should it belong? So even though it's a challenge today, I'm going to try and I'm going to talk to you about engineering education and where it can belong in K-12 schools. Where can it fit? And I'm going to assume that some schools in K-12, they might have an engineering teacher, but I'm going to take the perspective of a STEM perspective, or science and mathematics teachers integrating engineering into their curriculums. In 2012, in the United States, they released what's called the framework. This is a guide for teaching science. And in it, they talked about the importance of including engineering as an aspect of science education with mathematics applications. This was a pretty revolutionary document trying to account for how are we going to approach engineering education in STEM. Then the next generation science standards were released in about 2014-15. It started first with the middle level educators like junior high, 6th through 8th grades. They were the first to try to integrate engineering into their standards. But this is what they said. I think this is very important. I'm going to try and minimize. I could go back one. And then can we presentation mode? Oh, it shows. So this is what they said. This is revolutionary for engineering education. It says the next generation science standards, we call them NGSS, represents a commitment to integrate engineering design into the structure of engineering education by raising engineering design to the same level as scientific inquiry. When teaching science disciplines at all levels from kindergarten to grade 12, there are both practical and inspirational reasons for including engineering design as an essential element of science education. What do you think? Is this a very bold statement to raise science and engineering to the same level? I think that's a bold and promising statement. So what are some of these practical and inspirational reasons for elevating engineering design and science inquiry to the same level for all K-12 students? Here's some of the reasons that they list. 1, promoting engineering literacy. It's engaging. It addresses problems. It empowers students to identify problems and then use engineering design to solve problems in their communities. It helps us as communities and as a people to achieve solutions to problems. It is very place-based and relevant, meaning how I teach engineering in my community might look different how you teach engineering here because you have unique problems and constraints, and we can do that with engineering. We can place-base it so that we learn to solve problems in our own communities, and it's equitable for diverse learners. That means that regardless of your background, your education level, your gender, or any other issues that have not put us on a level of equality in the past can be put aside because everyone can have the opportunity to problem solve. I'll give you an example. I was working in a school, and in this school, we would say it's called a minority majority. That means that it was more likely that you would represent a minority group at this particular school. So there was probably 10 different languages being taught in this class. The teacher was a physics teacher and had never previously taught engineering design. But I was working with her on developing lessons that could be integrated into physics. So she held a competition to design a space instrument that would decrease the impact of a lunar landing machine, regardless of the language that the students spoke. They were able to participate because they worked in groups and communities, and they were able to work and solve the problem. The teacher reported afterwards, this was the first time she had seen this particular group of students engaged and in their own language, and that it was because of engineering design and problem solving, and it was not specific to their language that they needed to have to solve the problem. They could do it in whatever language they needed to. So engineering design can be very equitable. Well, before we can compare and say we need to elevate engineering design to the same as scientific inquiry, let's take a minute and talk about what is scientific inquiry. So scientific inquiry are the diverse ways in which scientists study the natural world and propose explanations based on evidence derived from their work. So in other words, in scientific inquiry, scientists will observe a natural phenomenon. For instance, when I was teaching this with my class, I said, look outside at all the icicles. I can't do that with you guys. I can't tell you to look at the icicles outside. So we'll pick a different problem. Let's look outside. It's very warm outside and humid. So the problem might be, how can we keep it cool inside when it's so hot outside? A scientist would look at this from a perspective and say, why is it so hot outside? An engineer would say, how can I keep it cool inside when it's hot outside? Just a little different way of looking at things. So in scientific inquiry, when they ask the question, why is it so hot outside? Or what can we do to create a cool room? when they ask these questions, there are 3 types of inquiry that they can use to answer the questions: a descriptive, or comparative, or they can do an experimental investigation. This is where a lot of people get tripped up with the specific field of geology. Not all geology involves experimental investigations. Sometimes it's descriptive. You simply want to describe the rock layers, or you want to describe a section that you're studying. Some are comparative, where you want to compare one question or one phenomenon to a different phenomenon. But scientific inquiry sometimes in school is taught as follow the scientific method. That's not true, because there's actually very different types of inquiry, and it depends on the question you ask and what you want to do. So if this is scientific inquiry, what do engineers do? When we teach science, we introduce this science phenomenon that initiates inquiry. So here's an example. If I'm a scientist and I look at this phenomenon, I see, what do I see? And now I can make observations, and that will initiate inquiry, so I might ask questions. I see a bee. I see something on the bee's leg. I wonder why that is being carried on the bee's leg. I want to conduct an investigation to see what is being carried and why it's being carried on the bee's leg. That's what science can do. It can initiate inquiry. However, engineering, design, and education looks slightly different. I don't introduce the phenomenon, I introduce a problem to my students. So on the other side of the screen, I have a problem. And what I see by looking at this, my students, I can say, make observations about this problem. They see, whoa, something's going on here. A 28% reduction in bumblebees, a 19% reduction in butterflies. Why are leaf cutters at a 50% decline? We have a problem, and I've identified the problem as a decrease in pollinator species. Maybe you don't think this is an engineering problem, but it absolutely is. A misconception that we have is that engineers build bridges and they're Mel's, or they fix things that are broke. Well, in K-12 education, we need to disrupt, or we need to confront this misconception. I'll give you an example. My daughter looks like me, blonde, and she's an engineer. She's a biological engineer. She didn't even know that biological engineering was a field. She didn't even know it existed. She thought the only thing that you could do in high school with engineering was robots. So when I suggested to her, Emery, you should be an engineer, she said, I don't know anything about engineering. I've never had an engineering class. I don't want to build robots. I said, that's not all there is to engineering. It's identifying problems in every field and coming up with solutions. But because she had never been taught this in her K-12, these options of being an engineer were closed to her, she thought. Thank goodness she has a mom that likes engineering and STEM, right? Otherwise, she maybe wouldn't have known. This is where we can combine science and engineering, not by focusing in K-12 on what engineers know necessarily, but we can combine them in STEM by focusing on what science and engineers do. What are their practices? And so we're going to, for the next minute, talk about what things do engineers and scientists have in common. We've already mentioned that one difference is inquiry versus problem solving, but let's look at some of these practices. They have identified 8 practices that scientists and engineers have in common. Note that number 1, scientists ask questions. Engineers will define problems. This is a slightly different approach, but it is still something that they work together to do. If I was to travel to Geneva, Switzerland, to the Hadron Collider, I would find scientists and engineers working together, hand in hand. It's very rarely that they are isolated or separated when we want to solve big problems. The second thing is that they develop and use models. Scientists do this, engineers do this. This is overlap. This is what they have in common. So if I'm a teacher in K-12, I can emphasize the development and the using of models. And you might just be thinking of a physical or a 3D model, but that's not necessarily right. They can do computer modeling, and this is where the technology portion comes in. Engineers have to develop the skill for computer modeling. So do scientists. So K-12 teachers can work on this skill. The third one is planning and carrying out investigations. Both do that. So this is a skill that can be done together in K-12. Analyzing and interpreting data. Both groups do that. They might take slightly different approaches, but they do that. Using mathematics and computational thinking. I know if you guys are engineering students that half your classes are in math. You have to take differential equations, and this is difficult math. But that is something that math, science, and engineering all have in common. They all need the mathematics for developing and using these computer models. But you also need all the mathematics for computational thinking for problem solving. 6 is scientists construct explanations. They want to explain the phenomenon or answer the question. Engineering wants to design a solution to that problem. Again, slightly different approaches here, but they work in coordination and together. 7 is they are engaging in argument from evidence. And as much as engineers may not like this, they have to be able to write and use disciplinary literacy. They have to be able to write like an engineer and write like a scientist. So sometimes in engineering, we still need that emphasis on literacy, writing, and reading, because all groups have to be able to engage in argument and use evidence to support that argument. And the last, which is also disciplinary literacy, they have to obtain, then evaluate, and then be able to communicate that information. If you are a researcher, an engineer, or science, if you cannot communicate by writing research reports, if you cannot effectively communicate, then you can't get the answer to the problem out to the world. And that's what we need to be able to do, is communicate. So these 8 science and engineering with some mathematics in there as well are these practices or the things that engineers and scientists do that we should be focusing on in K-12 education. Now here I have those same 8 practices, but this time they're slightly separated so you can see how science would use them slightly differently than how an engineer would use them. Now, I'm not going to read these all to you, thank goodness, that would be very boring, but I do want to give you a minute to look at them and then give you an opportunity to respond and talk back to me if there's anything on here that you find unique, interesting, surprising, or something that you'd like to share with our group. And I can take you my microphone if you need it too. Is there anything on here that you'd like to share, or anyone can, anything you find on this list that's interesting?
Thank you, Laura. I mean, we are engineering field, right? We see your presentation and your explanation is fully information and very good information. In Indonesia, we are implementing this K-12 education with the primary education. With we call this thematic. But in our engineering fields now, maybe we haven't implemented yet fully. That maybe our team or lecturer need to fully ask with the Laura how to implement this engineering practice for STEM education in education engineering field.
Okay, thank you.
Thank you. Assalamualaikum warahmatullahi wabarakatuh. My name is Amri from Mechanical Engineering Education Program. Maybe for the first, thank you for your time to explain this difference between science and engineering, especially about STEM. But I think this is for your information. In our country, there is vocational high school. Vocational high school. For the first, I want to ask you: is there any vocational high school in US? In US, is still there's vocational high school?
There are some STEM private schools, and then there are some high schools that offer either a STEM class or a separate engineering class, but not many.
Okay.
There are technical classes you can take in the high school, but not a full STEM approach with the inclusion of science and mathematics in together. So it's slightly different.
I think that's slightly different. In our country, vocational high school is especially the graduate ready to work. For example, for welding engineering, they have to ready become a welder. Now, I think slightly different. They not engineer. I think they're maybe we can say technologician. I think slightly different. If we apply the STEM, I think for the main concern not in engineering but in technological. Especially in our study program, our graduate for the teacher that high school. So first our concern to teach them to the vocational high school. I think we need your advice how to apply the STEM as I think not STEM education, not maybe STEM learning or STEM approach at there. I need your advice. Thank you.
Yeah, this is a big question everywhere in the world right now, because where does it fit and how do we make it fit? So we have the technology portion in our high schools as well. You can do the welding and you can do that, but it's not the emphasis necessarily on mathematics that you need to succeed in a full engineering program. Because one of the number one predictors of persistence in STEM fields is your math scores and how well you performed in math, not necessarily how well you performed in welding or other technical classes. In the United States, and I'm sure it's similar here, typically your engineering students have to perform very well in their science and math classes to be able to persist through a full degree. Is that the same here? With the high mathematics demand in the engineering degrees?
Yes.
Yeah, it just requires a lot of those. So this approach to including math and the science with the engineering is to help prepare students, not just students who are all going to go on to become engineers, because not all students are going to do that. Or not all students are going to go into STEM, and that's okay. But to create STEM literacy or a general awareness for problem solving, even if they choose not to go into a STEM field. So yes, this is a big problem, something we can keep coordinating on in the
Sorry,
future.
maybe this like a discussion.
Yeah, that's another big
Maybe
discussion.
our typically in here, the student or the graduate who expert in welder, that's lack of science, lack in science. Now, so I think we need to make their science is good too,
Yeah.
or science and engineering science,
Yeah.
and engineering sense. Yeah, because if we focus on in psychomotoric to the welding, their concentrate to science and mathematics is become less.
Yeah. Yeah.
That's the problem. Maybe you have some tricks or it's kind of that. Thank you.
So hopefully I can talk a little bit about that, because this is an issue everywhere. In the United States, their solution is to try and include more engineering design and science courses. But this is tricky because only 14% of the teachers in the United States report ever having had an engineering class. So how can you expect them to feel well prepared to teach engineering if they don't ever have any experience with it? So only 6% of middle school teachers and 7% of high school teachers have reported feeling well prepared to teach engineering design. Those are not good numbers. So the key here, and I'll get to this later, is what can we do in teacher preparation programs like this to help prepare science and mathematics teachers to include engineering design and put a bigger emphasis on STEM and not necessarily through the technical side of education. This is a big ask and something that we are working on ourselves. And different countries are trying to approach this differently. But my dissertation work was on helping science teachers develop engineering curriculum that could be taught in their classrooms. And I can share some of those tips and tricks with you guys today. One of which is that science teachers need to be taught the engineering design process as well as math teachers. Putting the emphasis on engineering design processes can help them understand the difference from inquiry so that they can teach both to their students. So the engineering design process that can be incorporated, I'm sure you guys are all familiar with this, and you probably teach this in your own classes and use this regularly, but I'll just go over this quickly. And this is a way that can help the science and mathematics teachers to include this. One, the engineering design series is a series of steps that engineers routinely follow to find a solution to problems. This is different from inquiry, where there may not be defined steps. But this is typically the process that engineers will go through. So the first one is to ask or define the problem. So what is the problem that needs to be solved? One, students need to be able to taught how to ask questions and how to define a problem. Maybe this seems really simple to you, but it needs to be explicitly taught. For instance, this is something that can be done in primary school. And we need to get away from focusing on just identifying something that's broken that needs to be fixed. For instance, if they're given a material, can they identify that this material is maybe not thick enough or not strong enough? Or the one that I like to bring up with students is the use of bioplastics, because they can identify that it's a problem, the buildup of plastics all over our world. So they can be able to look and identify plastics is a problem, and that can start at very early grades. Then they need to be able to taught how to do research into those problems, to be able to identify solutions. Not all engineers build and design things. Some of them evaluate systems. Some engineers look and they find a problem and already existing solutions, and then compare those solutions and see how they can make them better, cheaper, more marketable. And that's something that students can be taught to do as well. And they can be taught that in a science class very easily. So how can we find resources? Then they can be taught how to brainstorm possible solutions to the problem. And creativity is a very important aspect. But unfortunately, sometimes in science classes and math, we take the creativity out and we focus on memorizing facts and chapters in a textbook. But if we really want to have good engineers, we need to put the creativity back into the science classes for brainstorming and thinking up ideas. They need to be able to come up with and write a plan and consider the constraints that are on them. For instance, is this not feasible in an area because the materials are not available? Or this is our budget, this is all you have to work with. They can be taught to create a preliminary model and a prototype from which they can develop. And like we mentioned before, this can be done with computer modeling. And they need to be able to test it, see if it works, collect evidence, and then ask, can it be improved? Now, this is very difficult for K-12 students. They don't like to fail, and they don't want to be wrong. So if they build a prototype and that prototype doesn't work the first time, some students will shut down and they'll say, I can't do this. My rocket didn't soar, or my material didn't turn out right. And we need as teachers to be able to say, that's part of engineering. That means you're learning what it's like to be an engineer. Failing is a part of engineering, and then we try again. And this is an actual skill that can be taught in the science and STEM classrooms. Then we go back and we improve. Iteration is a very important part of engineering design that can be taught to our students. If they make something in a classroom or they evaluate something, we can say, can you make this better? Can you make this for cheaper? How can you improve on your previous design? But students will not inherently know those skills unless we teach them to them. So I have 3 QR codes up here that might be of interest to you. If you click your phone on the first one, I think it should work. I think so. Maybe, yeah, we'll try. If you need to move, we can move. Oh, that's true. And I apologize. My original slides collapsed. And so they collapsed. And so these were on separate ones, but I had to quickly throw them all onto one. The very last QR code, the one on the far right, is a document that you may be interested in having. This is a free PDF that you can download. It's called Building Capacity for Teaching Engineering in K-12 Education. They have some very good ideas in this document, and they also have some statistics on research that's already been done. And so that's something, if you do the last QR code, you can quickly download this document and have that to read. And I have found it to be a very helpful document if it's something that interests you. The other one that you might be interested in, if you go to this middle QR code, is a company that has developed, it's called, the one in the middle, it's called Why Teach Engineering in K-12. They have built a whole website that includes lessons that can be taught in science and mathematics classes that emphasize the engineering design process. So if you're looking for some helpful lessons, and they have them across grade levels, this can be a very helpful website. The very first QR code is another downloadable PDF. This one is an entire book filled with every topic that you can think of with a website. A lot of these are coming from government agencies that have developed free lesson plans for engineering and STEM. And they're all either a .gov or an .edu or a .org. And a lot of these companies have already invested time into helping to integrate science, technology, engineering, and mathematics. So it's worth checking out if you would like, because they are wonderful, helpful resources that give some helpful ideas on integration.
Very interesting. We found this. Oke, mungkin ada yang mau bertanya Kak, kira-kira kalau di engineering field itu seperti apa penerapan STEM-nya? Silakan, mungkin dari teman-teman ada yang mau menyampaikan atau dari mahasiswa. Nanti bisa pakai bahasa Indonesia, nanti akan disampaikan, ditranslatekan ke di bahasa Inggris. Silakan.
So, you guys can keep, or I have one more thing.
Oke.
So there is one more way that mathematics and science teachers can integrate the subjects with a focus on critical thinking, or what we would call 21st century thinking skills. And sometimes we refer to them as metacognition, being aware of our thinking. So one is that we sometimes have a tendency to do in education is only to focus on what scientists and engineers know. But we're trying to turn the focus on to what do scientists and engineers do, and be explicit about the engineering design process. So here is a problem. In the United States, they run what are called STEM camps. Yeah, they invite K-12 students to come to universities, and they'll put on a camp, and they'll call it STEM. And then at the end of the STEM activity, they'll ask the students, now that you've attended STEM, how do you feel about science? I feel really good about science. I've learned so much. I've had a fun time. Well, how do you feel about engineering? I don't know. Did I do engineering? Did we even do it here at the STEM camp? And the problem was they were actually doing engineering the whole time, but the teachers never even used the word or told them that they were doing engineering. They weren't explicit. They never said, this is inquiry. This is the engineering design process. Today, we're going to be engineers. Today, we're going to think like engineers and problem solve. Let's switch from a scientific mind and let's now think like an engineer and identify a problem. And because teachers aren't explicit and the students don't even know that they're doing engineering, they're not developing engineering beliefs, or they're not developing what they could if teachers had been explicit. So one way that we can integrate, we might already be doing it, is be explicit when we do it in the language that we use with the students. So one other way that I mentioned was through our thinking. So we call these cross-cutting concepts because they cross all STEM disciplines, have to use these ways of thinking. And when we can be explicit with the students and say, these are the cross-cutting concepts. Let's think using this skill. Now they know. So here's an example of a cross-cutting concept or a critical thinking skill that we should use explicit language. And the first one is patterns or pattern recognition. So we can use this language and say, here's a phenomenon, or here's a problem. Let's use the lens of our patterns thinking, and let's look for patterns. And now identify and write about the patterns, or let's ask questions about the patterns. The next one that we can use is cause and effect. So we ask our students, put on your cause and effect lenses. What could be causing this? What is the mechanism? What is the effect from this mechanism? And so we ask them to switch thinking. When we do this, we can actually increase test scores in students. Because now when you go to take what, I forget what they're called here in Indonesia, the test you have to pass at the end of high school, and you have to have certain scores, and then also in university, I can't remember it here. Yeah, the students, if they are taught these skills, sometimes they're given essays or things to write about, and they don't know what to write. They're very, very smart students, but they just don't know what to do. What if you gave them these metacognition or these particular skills, and now they said, I know what to write. I'm going to run through my cross-cutting concepts and approach this phenomenon or problem, and I'm going to write about each one. One, I'm going to start with patterns. I'm going to write about all the patterns that I see. Then they can switch to cause and effect. I'm going to talk now about when I approach this and put on my cause and effect lenses. What do I think are the causes? What's the mechanisms behind that? And then the effects. Look at this essay. This is already turning out to be a really great essay, but there's still more. The other one is scale, proportion, and quantity. If you can analyze or approach a problem from this issue of scale, do we need to scale it down or scale it up? Proportion and quantity, when they are taught how to think this way and be able to analyze using scale, proportion, and quantity, that's another very helpful cognition skill. The next one is systems and systems model. Students sometimes have a difficult time identifying the system. Is it a closed system? Is it an open system? Does this system influence any others? Is there a larger system that's and smaller systems within it? And so being able to be taught how to analyze from a systems thinking standpoint is very helpful to develop these engineering and scientific skills. The next one is energy and matter. They need to be able to identify what parts of a system constitute energy and what parts of the system constitute matter. And then being able to say, can we go back and forth? Or is there something in the system that is changing energy into matter or the other way around? Structure and function is the next thinking skill. And the last is stability and change. And so when we provide these critical thinking skills, and they also provide analyzing opportunities for our students, this is one way that we are integrating by using thinking and what scientists and engineers do. And I think I'm out of time because I talk too much. So I will go ahead and go back over to you guys. Yes.
Okay, so thank you, Professor Laura, for your great presentation, and that's interesting topic, especially for the engineering. Okay, now it's time for the participant to ask question. For the participant who are here, you can directly raise your hand. And for the participant who are in the Zoom, you can chat in the box and I will read it for you. Okay? Okay. You can stand up.
Yes. Okay, thank you, moderator. Hello, Prof. Laura. I am Agung. I'm from Mechanical Engineering Education Faculty, Sriwijaya University. I need a little sharing with you, and then I need some information with you about American education. So, in Indonesia, we have engineering major and education major. So we call the first we call pure engineering, and the second we call education engineering. Education engineering with pure education is different. Like for example, in our university we have mechanical engineering, and then we have mechanical engineering education. So it is different because mechanical engineering focus output for engineer for working in industry, and then mechanical and then education engineer is focused for like a teacher, instructor. So how about in America? Is there any pure engineering and then engineering education, or just one, or the same with in Indonesia? And then how about if someone want to be teacher in America? Because in Indonesia, if we want to be a teacher, we should study in engineer education for vocational teacher like this. So how about if someone want to be teacher in America? Just it.
Yeah, that's a good
thank you.
question. And it's kind of has a complicated answer. At Utah State University, you have the Teacher Education College. Then you have the Engineering Education College, which is at a different area, but not necessarily communicating with the other education department. Then you have a Career and Technical Engineering Education program in a totally different department and building. There are 3 different approaches. And so, but they don't always communicate and work together. So if you get a degree in engineering education, you would be certified to teach in the career and technical education programs in the United States. And so that would include in the middle levels what are called like the technical education. So you would teach how to work and build things with wood. And then in the high schools, they have more options. So that's kind of a confusing answer because there's 3 different approaches and they maybe approach things differently. But yeah, it's just complicated. Yeah. Yeah. Not all universities have a career and technical engineering education department. It's just Utah State is a agricultural school and they promote technology and engineering education. Not all schools also have engineering education in them as well. So it's complicated. With an engineering teaching degree, you could probably teach secondary, career and technical education classes.
Okay, thank you for your great answer. And is there any question? Ada pertanyaan lagi?
Okay, thank you for the opportunity. My name is Vigo. I am a student at Mechanical Engineering Education. I really like the idea of you say that we should implement the STEM education at K-12, right? So what I'm trying to say, like maybe in high school or something, student might be interested in maybe if we do have something, so they can see a problem, so they have to fix something. But in STEM, we can separate the science and technology and then mathematics. And the problem is, it is my problem. Like anyone have this problem maybe? Not every student have interested in science or mathematics. Maybe sometimes they interested in like technology or just they interested in engineering, but they don't interested and they don't even want to learn about mathematics or science, right? So what I'm trying to say, how in your experience, how do you make them interested in learning science and mathematics, especially with students that in high school or elementary school, because sometimes they don't like science and mathematics.
Because maybe in the past it's been taught just to memorize things.
Yep, that's right.
Yeah, and
Yep.
I don't want to just sit and memorize. I have degrees in science, 3 of them, and I don't want to just sit and memorize things either.
Yes.
Right?
Yeah.
So that's what I talked about, is putting the emphasis not on what they know, but putting the emphasis on the skills and what they do, and then putting it on how they think. So being taught to use those cross-cutting concepts, because even young children can love to go and look for patterns, where they can go and learn, or what do you think is causing this? But they also can enjoy the skills and the doing part. And so I think that's a good way to do that, is putting the emphasis back on the engineering design process and the skill-based learning and problem-based learning. Right. Yeah.
So basically, we need to get rid of uh, how to say it? Cara belajar matematika yang menghafal tuh.
Without memorizing.
Yeah, we need to get rid of memorizing.
Yeah, move
teaching.
away from rote memorization. We do that using the process of inquiry.
Yeah.
Yeah. Introduce a phenomenon, let them make observations, ask questions, carry out investigations, collect evidence, and then analyze that evidence. I've yet to meet a kid who hasn't liked to do that. That's fun, right? Inquiry, because that's how it's really done. And that's how it should be done. Instead of turn to chapter 8, we're going to memorize everything in the book, and then we're going to answer the questions at the end of the chapter. That's not fun, right?
That's not fun.
So we got to put that back on inquiry, engineering design process. And when we teach using those methods, it's highly engaging and, like she said, emotionally connected for the student.
Yeah, thank you.
Good question.
To add is the problem I mean the major of our engineering field is the problem. Since no, I mean not in the scientist, but in the engineering field is the problem. So we found the problem. We did the step of propeller is explain it that have observation and exploration until we are analyze and interpret of the solution. This is the we try to get the flow of this STEM in engineering field. So the engineering is our major. We build sciences, we build technology in integrated with our engineering field. This is
Okay. Is there anyone again wants to ask question here? Oh, in Zoom. Oh yeah. Okay. So I will read. Mhm. There is only one question in the chat box. There's from Anastasia Handayani. She asked that the main point of the engineering itself is it is a problem solver. Is it right?
Yes.
Now, and why? They say.
Oh, why is the emphasis on problem solving?
Yeah, problem solving.
Maybe in real an application of engineering jobs, maybe they don't feel like all they do is problem solve. But in K-12 education, if we can focus engineering to problem solving, then it's engaging for the students, and it's help building those critical thinking skills that helps us incorporate it with science and mathematics for teaching it in a K-12 setting. Those other aspects of engineering are very important, but in in K-12 with the younger students, we keep the emphasis on problem solving, especially when we're integrating it with other subjects to help it differentiate from inquiry. So it's not just learning about engineering, it's learning to act like an engineer.
Okay, thank you, Professor Laura Wheeler, for the answer. And that's a great answer. Okay, I think it's there. Maybe. Okay.
Thank you. Thank you. Let me introduce myself. My name is Ghazali. I'm from mechanical engineering as a student. I have one question for Prof. Laura. In our countries, the system of STEM learning is a no. I'm a student in vocational education. It's just now to STEM learning. And then the system is how to implementation the STEM learning. And then the STEM learning is no for the implementation. So we have a problem to implementation as a student. How to make it the solution for the implementation is a good thing. Thank you.
That's a good point because it is new. But the good thing about it being new, and you guys get to be the pioneers, and you can help implement it in your country in the way that works best for Indonesia. And so that's one of the exciting parts about it being new is you get to help shape what it's going to look like here in your country. Yeah, and although you guys are coming from mechanical engineering education, and that is wonderful, we also want to make sure we're promoting chemical engineering, biological engineering, aeronautics, and help our students understand that there's a lot of different opportunities in different branches and fields of engineering as well. And that's what STEM can do, because STEM will bring in several different types and branches and disciplines in science.
Okay. Is there any question again? Okay. From
Oh no, I'm scared. I'm getting a question from the team.
Thank you for chance. I'm really interested about the last previous question about how to mathematics is useful for to engineering educations in terms of the STEM education. So this my college defense of the her dissertation about the science, mathematics, sense making of mathematical equation in undergraduate science classroom. So this means that how to mathematics as the tool to solve the problem in the special case in science classroom. And the focus on the chemistry for they see our faculty member that defend dissertation. So in fact that in vocational education here we still spiritually to study engineering course, maybe mathematics course, assign course just spiritually, not the project like in STEM education. Basically, if we teach the engineering class, is it should be integrated with the other subject like mathematics, science. For example, the precision to measure something is the tool we use the mathematic course, and other subject, other problems. So that we believe that the problem in the world cannot solve by one subject matter, cannot solve by one major. So is the time is come up in the world, and we try to implement it, the STEM education, maybe just 5 years, previous 5 years, we struggle to put STEM in our curriculum. So we are in a university as the candidate of the teacher should be implementation STEM education in our course. Is this the point? I mean, just sharing. Yeah, thank you.
I think what you're asking is, should STEM be used for the integration so that we're making sure we're including the mathematics and the science with engineering? Is that what you're asking? Yeah. So STEM as an approach to learning, and I think that's going to go back. That's why I wanted to pull this up. The practices of science and engineers, they don't work without mathematics and computational thinking, which is a practice that scientists and engineers have to have. So, but are you asking that they should have a STEM class as part of the content, or are you asking instead of having a math teacher, science teacher, that instead that it should just be STEM? Is that what you're asking? I guess I just want to understand better what you're asking. Are you saying we should have a science teacher and a math teacher and a STEM teacher and engineering, or are you saying should we combine them into combine them together, or just teach it as an approach, a method for teaching?
Yeah, commonly here, teacher or lecturer don't teach integrated using science, using STEM education. Just teach spiritually. So how to give the capacity building to our teacher or student to be can integrated the several subject that useful for to solve the problem, like engineering, science, mathematics. This is a point. Yeah. Commonly, no, right now.
Yeah.
That we beginning to use at the curriculum right now. This is beginning. So to start is not easy, you know. Yeah, it's not easy.
It is in the same boat. They just enacted the engineering and the science standards in 2020 for secondary, but it was a pandemic year. And then the teachers didn't get teacher training. And so they just keep doing what they've always been doing, which is ignore the engineering standards because they haven't been trained and they don't know. And it's just new and they're starting to just roll it out and become comfortable with it. So you guys have the opportunity to assess how to make that work. It might look differently in primary school because the teachers take a more integrated approach. Anyways, they can combine and teach that way. In the secondary, that's where it gets trickier. Do you offer a STEM class and have STEM trained teachers, or are they still in their different disciplines? And this is a big question. I don't know that I know the answer to it. I just know that there are really great things that can happen when you do integrate engineering and all of STEM into a class. So with science, they're starting small with maybe 4 standards per year. So within the year in the science, just 4 integrated. Now you can do more than that, but that's kind of the minimum expectation. And maybe you could start small and try and integrate and then build and have more and more integration using STEM as a method. But Kathy, do you have any thoughts? She's worked on early childhood and elementary STEM. Most of mine's been in the secondary.
Not every lesson is going to integrate all of the STEM disciplines. So some of them will be forefronted with science and integrate and use mathematics and engineering. Some of them will be forefronted with mathematics. That's how our curriculum development has been. So it's an overall integrated curriculum, but each lesson doesn't include all of those content areas. That's one thing. So that lowers the bar and makes it easier to be able to achieve that goal. And you're looking at over the course of the curriculum that you're integrating rather than in every lesson, so that it's not forced or contrived, that they're meaningful in real problem-based ways.
There are some engineering courses where students in high school can take engineering. We don't have them in our state, but they are in some, where you can actually take an engineering course, and they tend to heavily emphasize mechanical engineering and structural engineering. And so one way they've got around that is if we put it into all the different science disciplines, then they're getting different approaches to engineering. They can get a biological or a chemical approach as well. And then the physics would be more the mechanical engineering. So there's so much to think about with incorporating engineering, just because there's so many different disciplines and domains of engineering as well.
Yeah, I agree with the Kathy that not only the engineering topic that we have to STEM, maybe we try the small thing to integrate it. Now we spirited course, physics, chemistry, mathematics, biology, and we try to how to integrate it the course with the engineering, right?
Mm-hmm.
We try to the small project about that.
Mhm.
So the question from the student, we are not interested with the mathematics.
Yeah.
So how to cope with the problem. So in engineering should have the mathematics as application. So we try to integrated mathematics in engineering. So the goal of the lesson is we write here that so mathematics is tool to solve the engineering.
Yeah.
Okay.
Since our teams explained that on the first semester, our student is learn about separate subject like mathematics, chemical, biology, or something. But in the second or third semester, we have engineering designs and maintenance system and another mechanical design, which conclude all integrated subject, science, technology, and engineering mathematics. The subject we used to get the student to involve in this mathematics, like get a problem of this design, then we make the measurement and the calculation, they interpret the design and they fix it, the design and redesign again to make the optimum solution. This is the our implementation right now in the STEM approach. I mean, we talk about with STEM approach. It is the minor, maybe we call it STEM class, but in the STEM approach in this. Thank you.
Okay. Okay. There's no more question, I think. There is. Oh, there is question. Oh, so many questions. Yeah.
Sorry if so many questions from me. I think this is very interesting what you said, but we need your supervision maybe. For example, we have possibility to integrate STEM in one subject in computer aided design (CAD). For your information, we use AutoCAD. Maybe if you don't mind, you can join with us to become maybe adjunct professors, or if you don't mind, yes, maybe for 1 or 2 semester. Maybe it is very interesting for us. We need further discussion for with you if you if you can to do that. Thank you.
And it's fun to think about that we like to think about. A lot of opportunities developing them and develop them. Very exciting.
Is that no? Okay. So I think that's all for the question and answer session. Okay. So to conclude this great presentation, let me conclude with a statement. So because STEM learning is new in our country, so let's be the pioneer to make it happen. So let we start from a small thing. Okay, I think. Okay, and that's I think that's all. And this is a great new information and great knowledge for us. Okay, thank you, Professor Laura Wheeler, for your great presentation. I think that's all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone.
Participating.
Before we going to continue the agenda, we just hear the azan first.
I just wanted to say that I have been here 6 times to work in Indonesia, in your beautiful country. And I said this to the other groups, and I'm saying for both of us. We don't speak your language. And I am always humbled, and I am very deeply grateful that you speak English to us, and your English is excellent. So thank you for making the effort to communicate with us. So thank you.
Well, we are going to continue this agenda. Now we would like to ask to our speaker to remain on the stage, and also we request the Dean of Teacher Training and Education to join us here to present a certificate of appreciations. Also, we invite Professor Sis Sumarni for accompanied the Dean. And also you too, Miss Professor Katie, to accompany Laura for certificate of appreciation. Okay. All right. Now give applause for our speakers. Okay. Maybe we can take a picture first. The dean and the coordinator of the committee. Yeah. Yes. Well, thank you. You may sit down, please. Okay, you may sit. Maybe the last taking picture will be the last after I close the yes, I close the general lecture. Well, ladies and gentlemen, now that conclude our general lecture for today. I hope you have enjoyed and learned abundant knowledge and information about engineering design in STEM education. Once again, thank you for Professor Laura Wheeler for the spectacular presentation. Let's give a round of applause for her. Also, we thank you for audience for your participation and contribution in this general lecture. I hope this general lecture can inspire you all. Finally, it's the end of our general lecture for today. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. And good afternoon. Okay. Now we just continue to take a picture together. Please, for Professor Laura Wheeler and Professor Kathy to come forward, and then the Dean, Professor Sis Sumarni, the moderator, the interpreter. Yeah. And then the lecture of mechanical engineering education. The lecture first, yeah. Be patient for the students. Okay. Okay, now we invite. No, just hold on the lecture. We just invite the students for take a picture together. All of you in this room, come. Well, thank you very much. It is the end of our general lecture. Thank you and good afternoon.